on limits, meaning of a limit. We're not getting into the rigorous proofs of limits. So I'm just going to work through a couple more examples here. And so from the previous videos, hopefully you see that we're gonna, a good idea here is to start by factoring the top, which is x plus 3, x minus 3, and then factoring the bottom, which is x plus 5, x minus 3. Okay. So if we were to substitute in 3 here, we would get division by 0, which would not be very helpful. But because we factored it, we have the ability to cancel out these terms. And then now we can do direct substitution. So on the top, it's just 3 plus 3. On the bottom is 3 plus 5. So that's 6 over 8, or 3/4. Okay. In other words, as x gets closer to 3, this function here, or this expression here, approaches 3/4. Okay. Let's look at another one, and then next example, where this time we have x cubed. And there's a couple ways to do this. So in this case, we can factor by regrouping. So I'm going to group these two terms, and group these two terms. And that's really just, I can pull out an x squared out of the first two terms, and that gives me x minus 2 plus x minus 2 all over x minus 2. So from here you can see that we can factor out x minus 2. So what's left here is x squared plus 1 all over x minus 2. Okay. So these two terms cancel, and now we don't have to worry about division by 0 anymore, so we can make a direct substitution. So this is 2 squared plus 1, or 5. Okay. So far what we've dealt with is situations where you have division by 0 and you don't know what happens at the point, so you can just use these algebraic tools to figure out what happens near the point. Okay. Let's keep on going here, and let's deal with a much more complex example. In this case, we cannot do direct substitution, because if you were to put in 0 in here, you would get division by 0. So what I'm going to do is work with this part. I'm going to work with this section here to hopefully get some results that will cancel out x. So I'm going to start by finding the lowest, just combining these two fractions together. So in the one fraction, I'm going to have 2 times 19 minus, and this 2 here, times this entire block here, which is 3 times 6 plus x plus 1, all divided by 19 times 3 times 6 plus x plus 1. Okay, and it's a little bit annoying because we have to keep writing the limit, and then this whole mess is multiplied by 1 over x. Okay, so I'm just gonna distribute. I'm gonna leave the denominator alone and just worry about the numerator. And do some simplification. Okay, so just 2 times 19 is 38. Multiplying all this out, we get, whoops, this is a mistake here. This should be a 1 still. So this is 3 times 6 and 3 times x plus 1 at the end. So keep on going here, and this is the limit as x approaches 0. And in the numerator, we have 38 minus 36 minus 6x minus 2, all divided by this mess, 19 times 3 times 6 plus x plus 1, all times 1 over x. Okay. But if you notice that in the numerator, I have positive 38, negative 36, and negative 2, and that all cancels to 0. And so now what we have is the limit as x approaches 0 of negative 6x over 19 times 3 times 6 plus x plus 1. This whole thing times 1 over x. Well then, this x and this x cancel each other out. So now we have negative 6 over this mess down here. But it's okay now for us to substitute in 0 because we don't have to worry about division by 0 anymore. So this is 19 times 3 times 6 plus 0 plus 1. Should be a 6. So this is just negative 6 over 19 squared, or negative 6 over 361. So the final answer is negative 6 over 361. Okay. So a little bit tedious, but you know, the idea is we have a problem here, so we try to work with this term until we find something that allows us to cancel out the problematic parts of the expression, and then we can do direct substitution. Okay. So I'm going to end this video here and start another one where we learn kind of a new trick. So all this is kind of just an academic exercise at this point, because we're not applying this to anything yet, but we want to build these tools so that we can use them later on. Thank you for watching, and have a wonderful day.